math people. Today's lesson focuses on multiplying polynomials. Alright, so last lesson we did some division. Let's switch it back to multiplying. Alright guys, so we're going to just do some examples here. So what I mean by multiplying polynomials, I mean you're multiplying two things. Alright, most likely you've got a number and a variable outside parentheses, and then you have this polynomial inside parentheses. And I call this a polynomial because there's two terms here. Alright, now all you guys are going to do is you're going to distribute. You guys have been distributing with me since 7th grade. You distributed in 6th grade, so you guys are experts at distributing. Alright, and what I mean by distributing is you take the outside number and you multiply it to both of the inside numbers. Alright, now before we get going, one of my pet peeves is if you see subtraction. So in this first example we have 4 times parentheses 2x squared minus 4. Alright, for the ease of distribution and eliminating mistakes, change that subtraction to adding the opposite or adding a negative. Alright, that'll make things a little easier. Now all we're going to do is we're going to distribute. So 4 times 2x squared. Now all I have is I have a 4 and a 2 that can be multiplied together. Alright, that's an 8. The x squared is just going to stay x squared. Plus 4 times negative 4 is negative 16. And here's my final answer. Alright, and that's a polynomial because I have two terms separated by an addition sign. Alright, 8x squared is my first term, negative 16 is my second term. Alright, now they're not always going to be that easy. Alright, we have to use some of our exponent rules that we've learned about over the last month. Alright, so example 2, we have 3x times 2x to the 5th plus 2. So again, I need to distribute because that's how you eliminate parentheses. Alright, so 3x times 2x to the 5th, 3x times 2. That will give me 3 times 2, which is 6. So my coefficient is 6. So you multiply the coefficients. Now I need to multiply the powers. X times x to the 5th is x to the 6 because you keep your base the same and you add your exponents. 1 plus 5 is 6. Alright, carry over our plus sign. 3x times 2. Alright, in this case 2 is a constant, but let's kind of treat it like a coefficient even though it's not. It's a constant. I'm going to do 3 times 2, which is 6. And this x is just going to tag along for the ride. Alright, it has to stay there. Alright, so my final answer, my simplified expression, 6x to the 6 plus 6x. Alright, one more example. Alright, let's say we have two variables going on. Alright, the more letters you throw in there, it tends to confuse things. Same process. We are just going to distribute. Alright, so I have 3xy. I need to multiply by 2x. So I need to multiply my coefficients or my numbers, 3 times 2, which is 6. Now I'm going to multiply my powers that have the same base. So x times x, we keep the base the same. We add our exponents. 1 plus 1 is 2. And that y doesn't have anything really to be multiplied. I can think of it times 1. I'm just going to keep it tagging along for the ride and attach it there. So 6x squared y plus, now I need to do 3xy times 1. Well, 3xy times 1 is 3xy because anything times 1 is itself. Alright, so there's my simplified expression. Alright guys, so really all you're doing is you're distributing, but it's a little more complicated because you might have to multiply two variables. Alright, if the variables have the same base, alright, you keep the base the same, you add the exponents. Alright, and you can always expand. I wouldn't recommend it though. Too much writing. Alright, so good luck.